Hello mathematicians, solve the equation cosine 4 theta is equal to cosine theta. What do we know? We know that cosine theta equal to c, and where theta is equal to plus or minus theta at 2n pi. This is the formula we derived if you look at my previous videos. Instead of the principal value, we use theta. So we can write that 4 theta is equal to 2n pi plus or minus theta. And so we have two options here. We can write that we have 4 theta with minus theta will give us 5 theta, and that's equal to 2n pi. Or we can have 4 theta with plus theta. When we take it to the other side, we have 3 theta is equal to 2n pi. So now we have theta can be equal to actually 2n pi over 5, or we can have theta being 2n pi over 3. Don't take my word for it. Substitute integer values for n and check that when you take cosine of theta, that value is also equal to cosine 4 times theta. Thanks for watching this video. My name is Alistair. I just realised this is not clearly on the screen. Let's write this, rewrite this. So this is 2n pi over 5, or 2n pi over 3. Thanks for watching this video. Bye for now. Hello. Find the general solution of the equation sine theta over 3 is equal to 0.5. We'll start by letting theta over 3 be identical to phi. This simplifies things so that we can write that sine phi is equal to 0.5. Now, that angle phi, which is the sine inverse of 0.5, is pi over 6. So our principal value of phi is pi over 6, and the secondary value is 5 pi over 6. Now, we know that phi is theta over 3, so which implies that theta is 3 times phi. So our angles phi are pi over 6 and 5 pi over 6, which implies that theta will be 3 times pi over 6, which is pi over 2, and 3 times 5 pi over 6, which gives us 5 pi over 2. Now this affects this factor of 3, so it's 3 times phi, which is theta. We'll also extend the range of values for theta by the factor of 3. So theta now is the principal value. We have pi over 2. And instead of 2n pi, we have 3 times that amount, which gives us 6n pi. And our secondary value, 5 pi over 2. This also is affected by the factor of 3. So this is our general solution. The substitution simplifies things, and we also need to be aware of this factor where theta is 3 times phi, which changes our values from pi over 6 to pi over 2 and 5 pi over 6 to 5 pi over 2. Thanks for watching this video. I'm Alistair, and I'll see you in the next one. Bye for now. Hello there. Find the general solution of the equation cosec theta over 3 is equal to 1.5. We know cosec is the reciprocal of sine. Cosec theta is a reciprocal of sine theta. So we can write that cosec a third of theta, same as writing 1 over sine 1/3 of theta, which is a reciprocal of 1.5. So if we let 1 over a third of theta be identical to phi, then we can write that sine phi is equal to this reciprocal of 1.5, which is equal to 0.67. That gives us a principal value of phi is 42.1 degrees, and the secondary value is 137.9 degrees. But we know phi is equal to this expression, which implies that phi is equivalent to 3 times theta. And so our values phi, our angles are 42.1 and 137.9, which implies that theta is 126.3 and 413.7 degrees. And our general solution again is affected here by this factor of 3. So our general solution theta its principal value, in this case 126.3, and we're adding 3 times 360 n degrees, which gives us 1080 n degrees, and the secondary value 413.7 is also 1080 n degrees. And that's his general solution. Thanks for watching this video. I'm Alistair, and I'll see you in the next one. Bye for now. Hello mathematicians. Solve the equation given values within the interval minus 180 to 180. We use tan A equal to tan B, and this implies that our solution set A, B, pi n and B. So A is 3 theta and B is theta minus 50 degrees. And this is our initial equation. Oops, forgot my theta. Add theta minus 50 degrees. This gives us 2 theta equal to pi n minus 50 degrees. So theta is equal to a half pi n minus 25 degrees. Now for values of n equal to negative 1, 0, 1 and 2, we have that theta is equal to minus 150 minus 25, 65 and 155 degrees. And that's it. So this is a case of solving an equation in the form tan A equal to tan B. A being 3 theta and B theta minus 50 degrees. And that implies that our solution set A will be pi times n at the angle B. And this is what we come up with, a general solution. And for specific values that lie within this range, we have n equal to negative 1, 0, 1 and 2. Thanks for watching. My name is Alistair. Bye for now. Hello there. Solve the equation giving values within the range 0 to pi inclusive. And the equation is sec 6 theta is equal to sec 5 theta. We know that sec theta is the reciprocal of cosine theta, so we can write this as 1 over cosine 6 theta 1 over cosine 5 theta. If you take the reciprocal of both sides, then we have something as simple as this. Cosine 6 theta is equal to cosine 5 theta. And if we make use of the relationship that cosine A equal to cosine B, implies that A is equal to 2 pi n plus or minus B. So let's see what we have. We have that 6 theta, which is A, that's equal to 2n pi plus or minus 5 theta. If we take the negative version, we have 11 theta is equal to 2n pi. So theta is equal to 2 11ths n pi. The other option, if we take the positive version of this, will give us theta is equal to 2 n pi. It doesn't give us for 0, if n is equal to 0, then theta is equal to 0, and we'll take care of that in this version of theta. But past that, if we go for 1, then we have 2 pi, which is outside this range, 0 to pi. So this is not an option of theta that we'll take. So for values of n equal to 0, 1, 2, 3, 4, and 5, we have that theta, our solution set, equals 0 2 11ths pi 4 11ths pi 6 11ths pi 8 11ths pi and 10 11ths pi. These are the solutions. Don't take my word for it. You can substitute it in this equation and make sure that the left-hand side is equivalent to the right-hand side. Thanks for watching. My name is Alistair. Bye for now. Hello mathematicians. Solve the equation given values within the range 0 to pi inclusive, and the equation is sine 7 theta is equal to sine 2 theta. We'll be making use of this equation. That's sine A equal to sine B. And this implies that the solution set A is equal to 2n pi add B and 2n add 1 pi minus B. Straightforward, we have A is 7 theta and B is 2 theta. So we have that 7 theta 2n pi at 2 theta, which gives us 5 theta is equal to 2n pi, so theta is 2/5 n pi. The other option here is 2n add 1 times pi minus b, and so we have 7 theta is equal to 2n add 1 times pi minus 2 theta. This gives us 9 theta is equal to 2n add 1 pi, so theta is 1/9. 2n add 1 pi. For values of n, we have our solution set theta is equal to 0, 1/9 pi, and this solution set includes both of these. 1/9 we have 2/5 pi, 1/3 pi, 5/9 pi, 7/9 pi, 4/5 pi, and lastly pi. So this was quite straightforward. A and B are obvious, and we can directly use this relationship that sine A is equal to sine B, and that implies our solution set A is equal to 2n pi add B and 2n add 1 times pi. This will give you all the odd versions of the solution, so the 1s, 5 and 7. Thanks for watching this video. My name is Alistair. Bye for now.